Okay, so good evening, all of you. Let us see the MCQs from ray optics now. कल भी हमने कुछ रे ऑप्टिक्स के एमसीक्यू स्टार्ट किए थे जो लेंस के ऊपर बेस्ड थे, तो आज भी हमको और कुछ एमसीक्यूज करने हैं लेंस के बेसिस पे. लेट अस सी द बोर्ड. Yes, this is what we have done last time. Actually, we are doing the question number 8. So question is that the convex mirror forms an image which is 1/4 the size of the object. If object is at a distance of 0.5 meter from the mirror, then the focal length of mirror is. So mirror का focal length हमको ढूंढ के निकालना है, और ये दिया हुआ है कि size of image is 1/4 of size of object. That means h dash upon h is going to be 1/4, which gives that v upon u is also equal to 1/4. Means that v is equal to 1/4 of u. That means v is equal to 1/4 of u. So we can just try to find out the focal length by using the mirror equation. Okay, mirror equation क्या है? 1 upon v plus 1 upon u is equal to 1 upon f, right? So if we use this here, then we can be able to get that. Yes, 1 upon v. Actually, v is going to be u by 4, right? So let us replace this by u by 4. This is u by 4. That is plus 1 upon u kept as it is, which is going to be equal to 1 upon f as it is. So that we can just get this 4 in the numerator, and we can get this 4 upon u plus, here it is 1 upon u, which is going to be 1 upon f. Means 4 plus 1 will be 5, and 5 by u is going to be 1 upon f, which means that f is going to be actually u by 5, where u is already given 0.5. Okay, so if we just put it here, yeah, we have to say consider these sign conventions here. Okay, u जो है, u का वैल्यू निगेटिव लेना होगा हमको. u is going to be negative, but v जो है, v is going to be positive actually. So therefore v is equal to 1/4 of u, but u is already negative. So in order to make this v positive, we'll have to consider this minus sign actually here, because of which there will be a minus sign at this point here, so that we can just get this minus of 4 plus 1 upon u, and then we can just get this as, actually it will be minus 3 upon u. Okay, so see here in the next step here, it will be minus 4 plus 1. So here it is minus 4 plus 1 upon u is actually 1 upon f, which means it will be minus 3 upon u is going to be 1 upon f, so that f can be written to be minus of u by 3. means it is going to be minus of. Abhi u is again negative. So that's why we have to consider it as minus of 0.5 upon 3, which is actually going to be minus of minus plus, and 0.5 upon 3 comes out to be 0.17 meter, which is actually going to be the correct answer, which is there in option A here. Okay. देखो या तो फिर ऐसा भी कर सकते, u का वैल्यू तो डायरेक्ट दिया हुआ है ना हमको, तो इसलिए ये हम बोल सकते हैं कि u is going to be minus of 0.5, which is already given, and the image is 1/4 size, मतलब image का जो size है वो ऑब्जेक्ट के हिसाब से 1/4 है. ओके, सो अगर ऐसा है तो इसका मतलब जो इमेज v अपॉन u जो है वो फिर कितना होगा, वो 1/4 होगा जरूर. So you can just get this v to be simply equal to 1/4 of u, but u is already given, so v is going to be actually a 1/4 of u, where u is actually minus of 0.5. But we have to remember here that this v is actually going to be positive, because convex mirror के बारे में जो हमने देखा था कि convex mirror always forms a virtual image, and the image of convex mirror is always formed at the right side of the pole. इधर ही फॉर्म होता है हमेशा इमेज कॉन्वेक्स मिरर का. तो इसके कारण यहाँ पे इमेज जो है उसका हमेशा पॉजिटिव ही, इमेज साइज हमेशा नहीं, सॉरी, इमेज डिस्टेंस हमेशा उसका पॉजिटिव ही रहा करता है. तो इसलिए यहाँ पे इमेज डिस्टेंस कितना रहने वाला है, 0.5 divided by 4, which means it will be 0.125 actually. So this is u and this is v. Once you get u and v, we can easily find out f, because we already have when 1 upon f is equal to 1 upon v plus 1 upon u, which means it will be 1 upon v, that is 0.125, plus 1 upon u, which is minus 0.5, and hence 1 upon f is obtained to be, so here 1 upon 0.125 kept as it is, and minus 1 upon 0.5 kept as it is. But as we already know that 0.5 का fourth fraction 0.125 है, तो इसका मतलब सीधा मतलब यह है कि 0.125 को अगर हम 4 से मल्टीप्लाई करेंगे तो 0.5 आ जाएगा जरूर. So let us multiply and divide by 4 so as to take the make the denominator same. So यहाँ पे 4 से हमने मल्टीप्लाई डिवाइड कर दिया, जिससे यहाँ पे 1 upon f जो है वो बन जाएगा एक्चुअली 4 upon 0.5 minus 1 upon 0.5, and then we can be able to get this 1 upon f is equal to 3 upon 0.5, which when simplified further gives this f is equal to simply 0.5 upon 3, which is actually going to be 0.17 meter. This is the final answer, which is there in option number A here. Yes. Okay. Let us move to the next question. See this 9th question. Just read the question carefully. Yes, it tells us that the focal length of a concave mirror is 20 centimeter, where an object must be placed to form an image magnified 2 times when the image is real. Yes. That means suppose this is the concave mirror. This side is just opaque and this is the reflecting surface. Okay. And suppose this is the principal axis. And focal length is given. Okay. So F is already given. Focal length of this concave mirror is given to be 20. But remember it is a concave mirror. So it will be minus 20. Okay. Minus 20 centimeter. Yes. Where an object must be placed to form an image. Okay. मतलब हमको object distance निकालना है. Where the object can be placed. So object distance is to be found out. So that the image magnified 2 times when the image is real. Okay. That means image is going to be real, means the image must be at the left side here. So image distance must be negative again. So it will be V, suppose V यहाँ पे वो image form होता है, and the image must be real, and at the same time image must be magnified 2 times. Okay. That means the ratio of image distance to the object distance is going to be actually 2 here, which means that V must be actually equal to 2 times of U. And even along with the signs, sign convention भी अगर consider करेंगे तो U is also negative, V is also negative. So we can just have this V is equal to 2U as a final relationship between this V and U, no doubt. And we want to find out U here in short. F is given already. So how can we get that? So we can just use the lens mirror equation once again, which tells us that 1 upon V plus 1 upon U, which is going to be 1 upon F. So that 1 upon 2U plus 1 upon U is going to be 1 upon F. So that it becomes 1 upon 2U plus, okay, so here we can just multiply divide by 2 and get this as 2 upon 2U, so that we can just take the LCM. And here 1 upon F. F is already given to be minus 20. Just put it here. It will be minus 20 here. Yes. And then we can just be able to get this 1 plus 2, that is 3 upon 2U, which should be equal to minus 1 upon 20. Yes. And then we can be able to get this U here. So just take this 20 in that side, so that we get this 3 into 20. Sorry. 3 into 20, and that is divided by 2, which is going to be minus of U here. That means minus of U becomes actually 30, right? 30 centimeter. Means U must be actually minus of 30 centimeter. That means the obviously U has to be negative. So that means the object must be placed at 30 centimeter from the mirror. That is going to be the correct option. Yes, let us see the next question then. Question number 10 here. Just read the question. A convex mirror of radius of curvature 1.6 meter. Okay, so R is given to be 1.6 meter. Has an object placed at a distance of 1 meter from it. The image is formed at a distance of. Okay, that means this is suppose the convex mirror. ये convex mirror है और उसके सामने यहाँ पे 1 मीटर पे ये ऑब्जेक्ट रखा हुआ है. So U is actually going to be -1 meter here. Okay, ऑब्जेक्ट का डिस्टेंस तो दिया हुआ है, रेडियस ऑफ कर्वेचर दिया हुआ है, मतलब इन शॉर्ट फोकल लेंथ दिया हुआ है. Focal length is always equal to R by 2 in case of the mirror. So it will be 1.6 divided by 2. That means it will be 0.8 actually. This is going to be the focal length. Once we get it, we can just use the mirror equation now. So we can get this 1 upon V plus 1 upon U equal to 1 upon F, which means 1 upon V plus 1 upon u, where u is actually -1, and that is in meter only. Here also the focal length is also in meter, no problem. So, and that is going to be equal to 1 upon f. F is the focal length of convex mirror. Convex होने से वो प्लस आएगा, तो इसलिए वहां पे उसको पॉजिटिव रखना है, so इसलिए वहां पे वो 0.8 बन जाएगा, no doubt. So this is the equation. Now, in order to find out this v, we can just transfer this -1 in that side, so that we get this 1 upon v is equal to 1 upon 0.8 plus 1 upon 1, means 1 only. So 1 upon v can be written to be simply equal to, इसको अगर हम क्रॉस मल्टीप्लाई करके सॉल्व करेंगे तो हमको मिलेगा 1 plus 0.8, that is to be divided by 0.8 on itself. That is going to be the value of 1 upon v. So that we can get this 1 upon v simply to be equal to 1.8 upon 0.8. So if we just take the reciprocal on both sides, then we can get this v to be simply 0.8 upon 1.8, which can also be written as 8 upon 18. Yes, so that it will be actually 9 upon, sorry, 4 upon 9. 4 upon 9 meter. Yes, yes, very good, Atharva. And that is also going to be behind the mirror. Why? Because it's going to be positive. Since v is going to be positive, we can conclude that the image must be actually here, behind the mirror. वैसे भी कॉन्वेक्स मिरर के बारे में हम ये जानते हैं ऑलरेडी, और ये याद रखो हमेशा कि कॉन्वेक्स मिरर के बारे में इमेज हमेशा बिहाइंड ही होता है, मतलब वर्चुअल ही होता है, जिसको हम बोल सकते हैं द इमेज डिस्टेंस इज ऑलवेज गोइंग टू बी पॉजिटिव, रिमेंबर. सो इट विल बी this fourth, C will be the correct option, no doubt. Let's go to the next question. 11th one here. Yes, just read the question carefully. A convex concave lens with unequal radii, a curvature radii of a curvature of glass has focal length of 40 centimeter. Okay, if it is immersed in liquid of refractive index 2, then it will behave like a convex lens, or it will behave like a concave lens, or what focal length you have to find out. Okay, so this is a important numerical actually. Just focus on this numerical, how it is to be solved. See here, a concave lens. Okay, तो लेंस के लिए हमको पता है ऑलरेडी कि ये सपोज कॉन्केव लेंस है, और उसका फोकल लेंथ भी हमको दिया हुआ है. तो फोकल लेंथ के लिए मतलब अब यहाँ पे क्या है ना कि वो जब इमर्स किया जाता है किसी लिक्विड के अंदर, अगर यहाँ पे लिक्विड है और लिक्विड के अंदर इस लेंस को हमने इमर्स कर दिया, ये देखो सेम लेंस इज जस्ट इमर्स इन अ लिक्विड. So what will happen in this case is the nature and focal length may change, and where the focal length in the air medium is given by the formula 1 upon f, which is going to be equal to mu minus 1 into, here it is 1 upon r1 plus 1 upon r2. As we know that the radius of curvature of this concave mirror, this r1 is going to be negative and r2 is going to be positive. So we can just get this sign conventions applied here, and we can just understand, we can get a minus sign here in front here. Okay, यहाँ पे एक माइनस साइन हमको मिल जाता है, ठीक है, ये बात याद रखो ठीक से. और just in general formula, if you just write it as here, the r1 upon r1 minus 1 upon r2. We are not considered the sign conventions so far. Okay, so लेकिन यहाँ पे जो म्यू जी है, तो म्यू जी यहाँ पे 1.5 दिया हुआ है, और उसकी वजह से यहाँ पे हमको मिलेगा 1 upon f. F is going to be 40 centimeter, or we can just say this 1 upon f in air. Okay, ये air के अंदर उसका focal length होगा, जो कि हमको ऑलरेडी दिया हुआ है. The focal length in air, which is given to be 40 centimeter. Just keep it in mind. Okay, and this mu is going to be mu g actually here. Yes, but what will happen if this same lens is just put in water? तो अगर यहाँ पे water के अंदर इसको हमने डाल दिया तो अभी क्या होगा? Formula, how will this formula get modified? So formula will become like this: 1 upon f in water or liquid, we can say, will actually be equal to, यहाँ पे mu g के बदले क्या आएगा पता है? It will be refractive index of g with respect to liquid actually, okay, minus 1, and then here it will be 1 upon r1 minus 1 upon r2, which is kept as it is here. So in this way, this is the second formula we can just get here. Remember, this is the refractive index of glass with respect to liquid, which is called as a relative refractive index actually. So if you just take the ratio of these two equations, तो ये पूरा जो इक्वेशन है, देखो ये पूरा इक्वेशन हम रखेंगे न्यूमरेटर में, ओके, ये न्यूमरेटर हो गया, और ये जो पूरा इक्वेशन है इसको हम डाल देंगे डिनोमिनेटर के अंदर, ओके, इस तरह से. Yes, so if you just divide this whole thing here, then we can just be able to get this as a RHS, sorry, LHS, and this will be actually the RHS here. Okay, that means you can just consider this as a fraction. ओके, तो ये हो गया हमारा फ्रैक्शन, जिसके अंदर हम देख सकते हैं क्लियरली कि ये जो पूरा फैक्टर है r1 माइनस 1 अपॉन r1 माइनस 1 अपॉन r2 वाला, ये पूरा का पूरा कैंसिल हो जाएगा बिल्कुल, ठीक है. बाकी जो बचेगा तो उसको हम सिंप्लीफाई करेंगे आगे, सो दैट वी कैन जस्ट हैव दिस सिंप्लीफाइड इन द नेक्स्ट स्टेप. तो अब यहाँ पे ये f लिक्विड जो है वो ऊपर जाएगा और f एयर जो है वो इसके नीचे डिनोमिनेटर में रहेगा. So in the next step, we can just have this as F liquid upon F air, which is equal to simply mu g minus 1 upon, here it is the refractive index of glass with respect to liquid, which will be actually mu g minus upon mu r, sorry, mu l, and that is minus 1 here. Okay, तो ये relative refractive index का formula है. Relative refractive index of glass with respect to liquid is always equal to the ratio of refractive index of glass upon refractive index of liquid as well. So here, if we just solve this in the next step, then we can be able to get this F liquid upon F air, which is going to be equal to, in the bracket here, mu g, where mu g is going to be 1.5, right? So it's going to be 1.5 minus 1, kept as it is, divided by, here it is 1.5 upon 2, and that is divided by minus 1 here. तो इसमें F air जो है वो दिया हुआ है, F air is already given to be 40 centimeter here, so we have to replace it that. So we get this F liquid upon F air, which is 40, is going to be equal to, so 1.5 minus 1 is 0.5 upon this 1.5 upon 2 comes out to be 0.75, right? So 0.75 minus 1, which happens to be actually minus of 0.25, and then we can be able to get this next step as F liquid upon 40 is actually going to be 0.5 upon minus of 0.25, okay, minus 0.25, so that we can just get this F liquid is going to be equal to minus of 0.5 upon 0.25 into 40, where this 0.5 is just double of 0.25. So we can just cancel it out and get this as minus 2 times of 40, and hence we can just get it as minus of 80. Now just see here, what does this minus sign tells us is, अभी देखो यहाँ पे माइनस साइन का मतलब क्या है कि ये देखो 1/r1 और 1/r2 का जो डिफरेंस है वो तो हमने कैंसिल कर दिया, it is going to be the same. But here minus sign just gives us an idea that the nature of nature of this lens in the liquid will just be reverse of the nature outside it, outside the liquid. That means yes, already it is the concave mirror, concave lens, right, outside the liquid. But when it is put in the liquid whose refractive index is just greater than itself, its own material, मतलब देखो ग्लास का मटेरियल का रिफ्रैक्टिव इंडेक्स कितना है 1.5 है और लिक्विड का कितना है 2 दिया हुआ है. तो 2 रिफ्रैक्टिव इंडेक्स वाले लिक्विड के अंदर जब हम 1.5 रिफ्रैक्टिव इंडेक्स वाला मिरर अगर या लेंस अगर रख देते हैं तो ऐसे केस में क्या होता है कि इस कॉन्वेक्स लेंस का नेचर चेंज हो जाता है, कंप्लीट नेचर विल बी रिवर्स्ड. दैट मींस जो कॉन्केव लेंस है बाहर वो अंदर जाके कॉन्वेक्स लेंस के जैसा काम करेगा, और अगर वो कॉन्वेक्स अगर होता तो अंदर जाके वो कॉन्केव लेंस के जैसे काम करता. दैट मींस हियर द नेचर विल बी रिवर्स्ड एंड एट द सेम टाइम the focal length will be 80 centimeter, which is available in option number A here. Yes, Kashish, correct. Okay, Shraddha, you have raised the hand. If you have some doubt, you can just put it in the chat box or just unmute yourself and tell it to me. Okay. ठीक है. I hope all of you have understood all this numerical. इस टाइप का बहुत सारे न्यूमेरिकल्स पूछे जा सकते हैं एग्जाम के अंदर. ठीक है. So let us see the next question now. Yes, the question number 12 here. It's very simple again. A thin double convex lens has radii of curvature of magnitude 40 centimeter and it is made up of glass with refractive index 1.65. Then the focal length of lens is nearly. Okay, so 1 upon f is equal to mu minus 1 into 1 upon r1 minus 1 upon r2 without sign convention. Okay, so here 1 upon f becomes equal to mu, which is 1.65 minus 1 into here 1 upon r1 is going to be 1 upon 40. But remember that this 40 is going to be in centimeter. So keep it in centimeter only so that we can just get the focal length also in centimeter only. So here 1 upon 40 minus 1 upon r2, where r2 is going to be minus of 40. Why? Because convex lens दिया हुआ है, correct? Convex lens के लिए क्या होता है हमको पता है already. Convex lens का r1 जो है वो actually positive होता है, okay? और r2 जो है वो actually negative होता है. R2 is negative, so therefore R2 के बदले हमको माइनस साइन रखना है. बाकी दोनों का रेडियस ऑफ कर्वेचर दोनों का सेम ही है, 40 सेंटीमीटर ही है, बट एक का पॉजिटिव एक का नेगेटिव तो होगा ही जरूर. एंड देन वी कैन जस्ट गेट दिस 1 अपॉन f which is equal to 0.65. okay, so this is 0.65 into here it will be 1 upon 40 plus 1 upon 40, which actually adds up to 2 upon 40. So 2 upon 40 means 1 upon 20 we can say. So 0.65 multiplied by 2 upon 40 we have to work out. So you can write this as 1 upon f is equal to 0.65 into 1 upon 20, so that we can just take the reciprocal on both sides and get this f to be simply equal to 20 upon 0.65. okay, which can also be written as 2000 upon 65. okay, so 5 से अगर reduce करेंगे इसको तो मिलेगा 5 13s and here it will be 5 400s. okay, and if you just divide it by 13, so 13 1s 13 3 जा 39, 1 carry 10 remainder 0.100 हो गया, 13 7 जा, it's okay, 30.7 means approximately it is going to be 31 centimeter here. Okay. So B will actually be the correct option. Yes, very good, Kashish. Again, and Atharva also. Yes, let us see the next question. A lens forms a virtual image 4 centimeter away from it. When an object is placed 10 centimeter away from it, the lens is a dash lens of focal length. Okay. A lens forms a virtual image of 4 centimeter away from it when an object is placed 10 centimeter away from it. Okay, that means suppose this is the principal axis, this is the lens. अभी ये हमको पता नहीं एक्चुअली वो कि कॉन्वेक्स है या कॉन्केव है, but चलो ठीक है, by default we can consider it as a convex, and it is given that the lens forms a virtual image of 4 centimeter away from it. Okay, that means the image is formed at 4 centimeter away. यहाँ पे image form हो रहा है. When an object is kept at 10 centimeter away from it, तो object जो है वो 10 centimeter away रखा हुआ है, ये object है. Okay, so this is not possible in case of convex lens. Can you understand this? Because convex lens के अंदर क्या होता है, देखो ठीक से, अगर ये मान लो ये प्रिंसिपल एक्सिस है, तो अगर यहाँ पे हमने इमेज ऑब्जेक्ट रखा, ठीक है, एक पर्टिकुलर डिस्टेंस पे, तो वर्चुअल इमेज जो उसका फॉर्म होगा ना, तो वो हमेशा मैग्नीफाइड होता है और उसकी वजह से वो उससे दूर होता है. तो यहाँ पे हमको वर्चुअल इमेज मिलता है, जो कि V जो है, V is always greater than U in case of convex lens. करेक्ट है? तो अगर ये लेंस अगर वर्चुअल इमेज बना रहा है और वो वर्चुअल इमेज भी उससे छोटा है, ऑब्जेक्ट से भी छोटा है, मतलब ऑब्जेक्ट से कम डिस्टेंस पे है, यस अथर्व. सो इसका मतलब ये कॉन्वेक्स मिरर तो कॉन्वेक्स लेंस तो हो ही नहीं सकता. ओके, सो सबसे पहली बात हमको ये समझनी है कि इट कैन नॉट बी द कॉन्वेक्स लेंस, वी कैन कंसिडर एज अ कॉन्केव लेंस ओनली. बट चलो ठीक है, बाय डिफॉल्ट इफ यू जस्ट कंसिडर दिस एज U, ये U जो है वो 10 है और V जो है वो 4 है, एंड सिंस इट वर्चुअल इमेज फॉर्म हो रहा है, तो वर्चुअल इमेज जो है उसको हम उसका डिस्टेंस जो है वो उसका जो डिस्टेंस है वो नेगेटिव कंसिडर करेंगे. ओके, सो वी कैन जस्ट कंसिडर इट एज U is going to be minus 10 centimeter and V is also going to be minus 4 centimeter, and we want to find out F. So we have the lens equation which tells us 1 upon F is equal to 1 upon V minus 1 upon U, so that we can just get this 1 upon F is equal to 1 upon V, which is minus 4 minus 1 upon minus 10, which gives 1 upon F is equal to 1 upon minus 4, or we can say minus 1 upon 4 plus 1 upon 10 here. So what is the LCM of 4 and 10? You can just say 1 upon F is equal to minus 1 upon 4 plus 1 upon 10. 4 और 10 का LCM बनता है 20. So we can just make it 20 by multiplying this by 5. And here we can make it 20 by multiplying and divided by 2 here. So that you can just get this minus 5 plus 2 in the numerator with this 20 once in the denominator. And that is going to be 1 upon F. So 1 upon F happens to be finally minus 3 by 20, means F must be actually equal to the reciprocal of that, that is 20 upon 3, and that is also negative. That means the focal length will be actually minus of 6.667 centimeter. That means negative focal length मतलब वो concave हो गया, तो इसलिए A option will be the correct one. Okay, nature is concave and focal length is 6.67, no doubt. So the next question. Question number 14 here. Yes, convex lens forms an image of object placed 20 centimeter away from it at a distance of 20 centimeter on either side of the lens. Yes. Suppose this is the lens and image of object placed 20 centimeter away from it. Okay, मतलब यहाँ पे अगर ऑब्जेक्ट रखा हुआ है 20 सेंटीमीटर पे अगर ऑब्जेक्ट रखा हुआ है तो उसका जो इमेज है 20 centimeter on either side of the lens. ओके मतलब यहाँ पे 20 सेंटीमीटर पे ही ऑब्जेक्ट इमेज फॉर्म हो रहा है. चलो ठीक है, ये इमेज है. If object is moved 5 centimeter towards the lens, then the image will move by what distance? Okay. That means अभी सबसे पहले देखो कि अगर 20 सेंटीमीटर ऑब्जेक्ट का अगर 20 सेंटीमीटर पे अगर इमेज मिल रहा है और वो भी कॉन्वेक्स लेंस का, तो the lens equation gives 1 upon f is equal to 1 upon v minus 1 upon u, and it gives 1 upon f is equal to 1 upon v. V is going to be 20 plus 20, yeah? And here minus of 1 upon u. U is going to be minus 20 actually, because u is always negative. So if we just put it here, then we can just be able to get this 1 upon f to be simply equal to 1 upon 20 plus 1 upon 20, which actually happens to be 2 upon 20, means f must be equal to 10. Okay, 1 upon 10 ये बनेगा, मतलब f becomes 10 centimeter here. Actually, focal length can also be found out in the second method, another method. That is, देखो ये कभी होता है कि लेंस का ऑब्जेक्ट और इमेज डिस्टेंस सेम ही होता है. ऐसा कब होता है? जब वो 2f पे होते हैं. याद है, ये 2f और ये 2f पे जब होता है ना, मतलब ऑब्जेक्ट जब 2f पे रखा जाता है तभी जाके इमेज 2f पे फॉर्म होता है. तो इसका मतलब अगर ऑब्जेक्ट और इमेज दोनों अगर सेम डिस्टेंस पे अगर फॉर्म हो रहे, तो इसका मतलब ये है कि द डिस्टेंस, दैट डिस्टेंस एक्चुअली मस्ट बी डबल ऑफ फोकल लेंथ. That means this 20 centimeter must actually be double of focal length. So focal length must be 10 centimeter only. So that is the simple method to find out the focal length. Chalo, theek hai. But we have found it out. Now we have to just solve this question. Second question here. If object is moved 5 centimeter towards the lens, that means the actual object distance now is going to become 15 only. Why? Because already it was at 20 centimeter and it is moved 5 centimeter towards the lens. That means the actual object distance is going to be 15 centimeter now. So we can just use the convex lens equation once again and get that 1 upon f is equal to 1 upon v minus 1 upon u, which means 1 upon 10 is equal to 1 upon v, which is to be found out. And here it is 1 upon minus 15 actually. Okay, because object distance has been changed. The new object distance is minus 15 because the lens object is moved towards the lens by 5 centimeter, right? So here if we just solve this further, then we get this 1 upon 10 is equal to 1 upon v plus 1 upon 15. If we just take this 1 upon 15 in that side, we get this 1 upon 10 minus 1 upon 15 is equal to 1 upon v. So that in the next step, we can just get this. Okay, यहाँ पे LCM जो 30 मिल रहा है. So we can just multiply this by 3 and divide also. And here we can just multiply divide by 2 here. So that we can just get this 3 upon 30 minus 2 upon 30. And that is going to be equal to 1 upon v. So that this becomes 1 upon 30 is equal to v. 1 upon v means actually v is going to be 30 centimeter. So this is the final image distance, but already image was at 20 centimeter distance, right? And if it is moved to 30 centimeter distance now, that means it is shifted by 10 centimeter only. So we have to find out the शिफ्ट इन द इमेज डिस्टेंस। तो इमेज डिस्टेंस कितना शिफ्ट हो रहा है 10 सेंटीमीटर से, और वो भी टुवर्ड्स नहीं बल्कि अवे फ्रॉम द लेंस। ठीक है, लेंस से दूर भाग रहा है वो 10 सेंटीमीटर डिस्टेंस से। सो यू कैन जस्ट सिलेक्ट दिस डी एज अ करेक्ट ऑप्शन। यस, वंस अगेन वेरी गुड अथर्व एंड कशिश, you are correct. Okay, let us move to the next question. Okay, just read it carefully. A virtual image twice as long as the object is formed by a convex lens. Okay, matlab virtual image is h dash, which is twice as that of the object. When an object is at say 10 centimeter away from it, that means u is again given here. U is given to be minus 10 centimeter here. And image जो फॉर्म हो रहा है तो, और वो वर्चुअल इमेज दिया हुआ है। देखो अभी, हाँ ठीक से यहाँ पे हमको और केयरफुली सॉल्व करना है इसको, क्योंकि अगर ये कॉन्वेक्स लेंस है जो कि दिया हुआ है यहाँ पे देखो, और उसके सामने हमने ऑब्जेक्ट कहाँ पे रखा है, -10 पे रखा है। ये -10 डिस्टेंस इज द ऑब्जेक्ट डिस्टेंस। ओके, तो यहाँ पे ऑब्जेक्ट रख दिया, जिसके कारण वर्चुअल इमेज फॉर्म हो रहा है, और वो भी ट्वाइस एज लॉन्ग एज द ऑब्जेक्ट। दैट मीन्स अगर ऑब्जेक्ट इतना है तो वर्चुअल इमेज उसके डबल साइज का फॉर्म हो रहा है। डबल, दैट मीन्स इट्स डिस्टेंस विल आल्सो बी डबल, so it will be -20 actually, and it will be on the same side because it is virtual image, correct है? तो -20, okay. And a real image twice as long as the object will be formed when it is placed at the distance of dash dash from the lens. Okay, not lens. Okay, so see here. So from this we can be able to get the focal length of the lens. Can you? V is given to be -20 centimeter, because virtual first statement में जो दिया हुआ है ना, तो वो virtual image है। तो वो virtual image of twice as long as the object is formed by convex lens when the object is 10 centimeter away from it. So 10 centimeter is going to be the image distance, object distance, and the image distance must be -20, just because the object is twice। और देखो यहाँ पे, क्योंकि h dash upon h जो है वो अगर 2 दिया हुआ है, तो the same thing should be the ratio of vi upon u also। v और u का रेशियो है वो भी 2 होना चाहिए, जिसका मतलब v must be equal to 2 times of u, and hence we are obtained this as v equal to -20 centimeter here, and it is negative because it's a virtual image. Okay, so from this we can just be able to get this f. So 1 upon f is going to be 1 upon v minus 1 upon u, so that we can just put these values v and u. So 1 upon -20 minus of minus plus 1 upon 10, so that we can just solve this and get this 1 upon f is equal to, इसको 2 से मल्टीप्लाई डिवाइड कर दो, so that we can get this -1 plus 2 there in the numerator and 20 there in the denominator, so that we can get this 1 upon f is equal to 1 upon 20, which means f must be 20 actually centimeter. Okay, so f becomes equal to 20 centimeter. Once we get f, we can just try to solve the second line here, second part of the question, which is a real image twice as long as object will be formed when it is placed at a distance of, that means we want to find out the object distance now. Yes, option. Okay, let us check. See here, now this diagram will be somewhat modified. अब यहाँ पे डायग्राम जो है वो हमको अलग ड्रॉ करना होगा। ये जो डायग्राम हमने ड्रॉ किया है, it is for the first statement, but if you just focus on the second statement here, then suppose this is the principal axis, this is the lens here. Now we want to find out where the object has to be put here so that the image will be formed at real image will be formed at right side, and it will be at twice as long as the object. That means again v must be equal to 2 times of u here. समझा ठीक से? v जो है वो डबल ऑफ u होना ही चाहिए यहाँ पे भी. तो इस केस में यहाँ पे क्या है ना कि v का जो वैल्यू है तो वो एक्चुअली यहाँ पे -2u होगा. समझा क्यों? क्योंकि u इज ऑलरेडी नेगेटिव. ओके, u is already negative and v is positive. So in order to make this v positive, we'll have to consider its minus sign here. देखो ठीक से यहाँ पे v is equal to -2u, जबकि यहाँ पे हमने v is equal to 2u यूज किया था. v is going to be equal to 2u in this first case just because v was also negative and u is also negative. So minus sign यहाँ पे नहीं आएगा, but यहाँ पे जरूर आएगा क्योंकि यहाँ पे रियल इमेज फॉर्म हो रहा है. रियल इमेज हमेशा पॉजिटिव इसका डिस्टेंस होता है, जबकि u is always negative. So in order to cancel out that negative sign of object distance, we'll have to consider a minus sign here in this equation here. Okay, so अभी फिर यहाँ पे हमको लेंस इक्वेशन यूज करना है फिर से, जो बनता है 1/f is equal to 1/v minus 1/u. Okay, so f is already 20 here, so it is replaced here. 1/v, v is going to be -2u actually. Okay, -2u and minus 1/u. Actually u is not known in this case here. Don't take this u as it is here. ये पहला वाला जो u था वो मत ले लो यहाँ पे, क्योंकि हमको यहाँ पे अभी निकालना है ना डिस्टेंस ही तो निकालना है, ऑब्जेक्ट डिस्टेंस ही निकालना है. तो इसलिए u का वैल्यू यहाँ पे सब्स्टिट्यूट मत करो. u is to be found out. Only thing is it is given that the real image as twice as long as the object is formed. ये दिया हुआ है, तो इससे हमको ये इक्वेशन मिल गया और उसको यूज करके हम यहाँ पे यूज करेंगे इसको. तो अब यहाँ पे 1/20 comes out to be actually here it will be, ये माइनस साइन ऊपर डाल देंगे और यहाँ पे 2 से मल्टीप्लाई डिवाइड कर देंगे. ओके, जिससे वो हमको मिल जाएगा -1 -2 in the numerator, and here in the denominator it will be 2u which is taken once. Okay, and then we can be able to solve this further and it will get this 1/20 which is equal to -3/2u, so that u becomes equal to, u हमको निकालना है तो u को उधर लेके जाएंगे और 20 को उस तरफ भेज दो, तो ये बनेगा -3 into 20, that is to be divided by 2 here, so that we get this u is equal to -30 centimeter. Okay, माइनस तो होना ही है वो, so it's 30 centimeter. B is going to be actually the correct option. Yes, very good, Atharva. Okay, so these are the 15 questions we have solved already in this today's lecture. Let us solve remaining sums in the next lecture tomorrow. Okay, yes, let us stop this lecture here. Thank you all of you.